s squared plus 1 all over x raised to the power 4 1 dx. Well, we're supposed to integrate this, and it looks very interesting. So, I think, any suggestion? There's plus. Okay, so I think what we can do is we can use substitution, but that will be more complicated. Okay, or you can also expand this. Okay, this into partial fraction. Okay, so that we use the partial fraction to be able to solve that. But in alternatives, and I think we can also multiply both of them by a certain factor. See, the way I see s squared, I would like to eliminate the s squared to see what I can do something with it. So I say multiply both top and down by 1 over s squared. So then our integral, which is s squared plus 1 over x to the power 4 plus 1 dx. So we're multiplying both here and down here by 1 over s squared. So 1 over s squared is 1 over s squared, and here by 1 over s squared. So if that becomes the case, then this equation, or this integral, will be 1 plus 1 over s squared all over s squared plus 1 over s squared dx. Well, that is organized. Okay, so if that is the case, let's see what we can do. If we look at the bottom one, there's s squared plus 1 over s squared, which can be written as s squared plus x raised to the power negative 1 all squared. It's a perfect square. So then, if that is the case, we can say that s squared plus 1 over x all squared is given as s squared minus 2x multiplying 1 over x plus 1 over x all squared. Okay, similarly, we can also say that this can also, if this is going to be minus, that's what we get. That's what we get. When this is a plus, we are going to get s squared plus 2x out 1 over x plus 1 over x squared. Okay? Look at it very carefully. It's just beautiful. So this will help us to be able to simplify the integration. Okay? Now, if I decide to make this one, call this one A, and this B, then A will be x minus 1 over x all squared. Then B will be x plus 1 over x all squared. So that is the explanation. Okay, now, if you look at it very carefully, by observation, you will see that this, we can split it. Yeah, we can split it in this way. How do you split it? The bottom one we can decide to use this equation so that our integration will be 1 plus s squared all over s squared, okay, plus 1 over s squared dx. You see, but if we put 2 here, okay, if we put 2 here, okay, when we say plus and a plus here, when we put 2, when we put 2 here and we subtract 2 here, we subtract 2 here and we add 2 here, this expression, its integral, can now be written as 1 plus 1 over x squared all over x minus 1 over x squared plus 2 dx. Look at it very carefully. So, if we are able to achieve this, then we can do something. Because if we decide to, let's expand our board. If we decide to integrate our expression, we see that we have the integral, and the top one is 1 plus 1 over x squared. Then after this, after here, you see that this, we are able to simplify into this. Now, let's try and use the U substitution. Okay, so let's U to be equals to the denominator, which is x minus 1 over x. Okay, then look at it. When we differentiate this, du will be equals to 1 plus 1 over x squared into bracket dx. Okay, when we differentiate that, that's what we get. So, in a nutshell, our dx, it will be du all over 1 plus 1 over s squared. If you look at it very carefully, you will see that here it helps us because the top one over here is similar to what we have. You see, this is similar to the top one. Okay, the top one. So therefore, let's have a look. If that is the case, then let's substitute these parameters into the equation. Okay, into the expression. So our expression is integral 1 plus 1 over s squared all over x minus 1 over x. We said u multiplying dx, and our dx is given as, let me use this one, it's given as du all over 1 plus 1 over s squared. Okay, so if you look at it, that's what we have. Further, something can cancel. So note that 1 plus 1 over s squared will cancel each other in our expression here. So if we say that our 1 plus s squared will cancel 1 plus s squared over here. Okay? Isn't that beautiful? This one will cancel this. So we'll be left with 1 integral du over u. Okay, as you can see, if we look at what we've done, so our u, where is that? Our u was equals to that. Okay, so meaning this will be that divided. So 1, let me look at it. So plus 2 over here is still there. So 1, this is plus 2, that we shouldn't omit it. Okay, so this, our u, okay, is given as that. When we look at the equation, the bottom one over here, this one was a square. The one I've I've highlighted red. So meaning our u here is squared. So this one will become u squared plus 2 du. Okay, the simplified form. So our integration become that. So how do we integrate this? How do we integrate the u over u squared plus 2? Well, this is a bit daunting. After cancelling this and that, it's supposed to be easy for us. Well, this can also be written as du all over u squared plus square root of 2 all squared. Yeah, if we do that, then we can use the tan inverse function to be able to sort it out. So therefore, our integral du all over u squared plus square root of 2 all squared will give us, this will be 1 over root 2, since that's the constant over here, and a tan inverse of u root 2, which can be written as 1 over root 2 tan inverse will bring the 1 over root 2 out, 2 out, multiplying u. But we know u to be u, but u is equals to x minus 1 over x. So this will give us 1 over root 2 tan inverse of 1 over root 2, okay, into bracket x minus 1 over x. So our integration, squared plus 1 all over x raised to the power 4 plus 1 dx give us this. So let's go back and break it out. So the first one is the integration has been given to us. We know the integration to be it looks a little bit tricky because we have x squared plus 1 dividing x to the power 4 plus 1. Okay, so as you can see, x squared plus 1 over x squared, x to the power 4 plus 1 dx will multiply through by 1 over x squared, both the top and down. And that one gives us this. After simplification, this explains why we got to this a. So we decided to use 1 minus 1 over x all into bracket squared. Why? Because if we have x squared plus 1 over x squared, when we add 2 here and subtract 2 over here, this will give us this expression. Okay? So this one helps us to be able to integrate it. So eventually, you see, the expression, this expression, eventually, this expression, 1 plus 1 over x squared, okay, into bracket, over x minus 1 over x into bracket, plus 2. This helped us to integrate it because we decided to make u to be equals to x minus 1 over x. And after differentiation, we had du to be equals to 1 plus 1 over x squared. And we make the dx the subject. Okay, so we have this. dx is equal to du over 1 plus 1 over x squared. Okay, now put it back into the equation. We have 1 plus x squared. And bear in mind that this is u. So that is u squared plus 2 over here. Okay, then since we want to use the tangent inverse, we decided to make the 2 as a square root of 2, because when we square it, we get back to 2. So after that, we used this substitution of tangent. So du over u squared plus square root of 2 gives us 1 over root 2 tan inverse of u over root 2. So then I expanded this and I had that. But we know u is equal to x minus 1 over x. So this one becomes 1 over root 2 tan inverse, all out 1 over root 2 into bracket 1 minus x, 1 minus 1 over x is the final answer. Thank you very much. Please subscribe to the channel and hope to see you around again. So this is a beautiful equation that we have been able to do it.